So today we're going to talk about InnoDB data recovery. It's not, this one is not very high level, it will be a low level, but technical talk, but which is fun also, I would say. So let's start with the presentation. So my name is Frédéric Descamps. I am on a lot of social media, so you can find me usually as LeFred. This is how everybody knows me. I am MySQL evangelist, and I started not 30 years ago with MySQL, but almost, because 3.20 was in 1997. And I have in my luggage the CD, in case somebody wants to see it. I am living in Belgium, so you will see there is one thing with the jet lag is that sometimes I need to look for the words. And it's 1 a.m. for me right now, so I may be a bit tired. But so be patient with me if I'm looking for a word. As you can see, I shave my beard for the mic and also to have a very good custom experience to come in the US. So, but usually I look like more like this. So so we're going to talk about InnoDB data recovery, and you will see that on this talk, it is very important. It's what MySQL and what the community of MySQL brings to MySQL, because most of the tools I will show you today are not even made by us, but they are made by the community. And so this is why we are very happy to have a great community, and you will see how we can use pieces from the community all together. And we saw that also earlier on the Yelp talk, if you were there. They were using plenty of external tools, and we will do that also for this session. So why should we do data recovery? First of the thing, I hope you never have to do that, but I've made plenty of them when I was consultant, and I'm sure some people doesn't follow the best practices. And so the first one is no backup. If you have no backup or invalid or broken or untested backup, maybe you will have to do data recovery one day. And I know a lot of people, they say, oh, I have a backup. Oh, of course I have a backup. Yeah, we have. Then they have an issue, they need to restore. Is it normal that the size of the backup is 0 bytes? Not really, I guess. So test your backup. Then you don't have bin lock. So you have backups, but you don't keep your bin locks, or you delete them, so you won't be able to do point-in-time recovery. So the data might be lost if you have something wrong happening, and then data recovery will be necessary. You don't have a replica. If you have replica, if something crashed, the disk crash on the primary, then it's okay, the data is still there. On a replica, I still have the data. But if you don't have the replica, you may need to do data recovery. Disaster recovery plan. If you don't do backups, if you don't take your bin locks, if you don't take replica, I'm almost sure you don't have a disaster recovery plan, right? So this is for fun. If you don't do all the rest, sure, this one you don't have. And also sometimes just because we can. So let's do it together, right? So, and we like to live what we call the white life. It's fun, but I did really a lot of data recovery in the past. So people say, yeah, it never happens. It happens. And last time I gave a talk like this, I had some people coming, oh, I wish I knew this last week, but it happened. So I was telling that I was working about tools from the community, and this is the list of the tools I'm going to use. And the first one is when we did MySQL data recovery, so we are using a tool set. And if you have done data recovery in the past, who did data recovery already for InnoDB in the past? Nobody? Oh. That's nice, but usually there are a lot of people who has done it at least once. And for that, there were some tooling. And for example, there was a Percona data recovery tool for InnoDB that is not updated since 2011. Then there was undrop for InnoDB from TwinDB, where the last commit is 2018. And same from, there was a fork undrop InnoDB by Marco Tusa, which also was a last commit from 2018. Since 2018, MySQL and InnoDB has changed a lot. So this tool won't work. And these tools are really a pain to use. Every table you wanted to recover, you had to recompile in C++, the tool, change stuff in C++, and that was taking ages. So now there is a new tool made by the NVIDIA engineers, which is called InnoDB _RS. So it's written in Rust, and the first commit was in 2024, and the last commit it's August 10th, 24 also. So it's a recent tool, and no new commits because not needed for the moment, but this is what we're going to use today. But I also use other tools. So I use IDB to SDI. This is part of the MySQL when you install the MySQL server. I will use SDI to DDL, made by Marcello Altman. You may have seen it at the conference. He was here. He's a MySQL rockstar. He's an Oracle ace also. So, and he created this tool. I will use InnoDB sort. We're going to use MySQL shell. So this is made by us. I will use IBD Ninja. This is not mandatory, it's just optional. But I just saw this tool and I said, oh, it looks cool. Let's try it. And of course, a Linux box. If you want to do that on Windows or in Mac, I have no clue how you can do it. I always use Linux for that. So the prerequisites for data recovery, usually if you are a good DBA, these steps is what you should do. But like I said, if you are here to attend how to recover InnoDB tables that you may have broken, you may have not done what a good DBA has to do. But the first, you need to have a physical backup, right? If you have an issue with the InnoDB table, or you delete an IBD file, your disk is crashed, if you have a recent physical backup, it's okay. It will be possible, but here we don't. Then you could have a recent logical backup. Scott, my colleague, shows you earlier how to do very fast dump and load, logical dump and loads of the database instance in parallel, but here we don't have. But if we had, it was easy to recover data. You could have also a DDL dump. So DDL dump, as a DBA, I always tell people you should have a view of all the data, how it is designed, the tables, and that helps. But when you need to do the InnoDB recovery, most of the people say, yeah, I don't remember really the schema of the table. We forgot, we lost it. So here we don't have it. So we will need to create it together, and we will show how to create it. Then you need to have the SDI file. SDI, every DBA keeps the SDI of all the IBD, right? Who has the old SDI? This is what I was thinking, right? So, but you should usually, but here we don't. Then know your space ID. Everybody knows the space ID of the table, right? Okay, same answer. Nobody does. And to be honest, even when I manage a database, I don't really know that. It's normal, right? But if you have this, it's very easy to do a recovery. And of course, the first one is the most easy. The last one helps. But if you don't, I will show you how we can do. So if you want to do that well, a DDL dump, you can use MySQL shell, and it has DDL only, and you will have all the schemas designed, very easy to do. So this is the way to do it, and then just an example how to create. So you don't dump the data, you just dump the structure of your database. But here, let's forget about it. We don't have it, but if we would have done, this is what we have, then we see the structure of the table. It's easy. Here, the employee table, we know what's inside. But if we don't, then it's more complicated, and we could have the SDI. So SDI is for the serialized dictionary information that is part of all InnoDB tablespace. So before MySQL 8, before the data dictionary, all the structure of the tables were in the FRM file. But we don't have FRM anymore. Everything it's in InnoDB, and so with the SDI we can extract that information and get the table space, the tables design with all the metadata. And so, for example, you can create IBD to SDI using this command. And then, if we look at it, we have all the information. The space ID, this is the way in information schema to find the space ID. So for example, here we can see that the employee tables has the space ID number 2. Right? So this is easy. So if you want to be prepared, I always advise people to save that information somewhere regularly. So now we say, okay, but we haven't done all this, so let's do InnoDB data recovery. And to that, we start with a system. I use MySQL Community Server 9.1.0. I use a MySQL data dir, which is a dedicated disk for the data, which is we try to always recommend to people to have the data in their own disk or multiple disks. And we use the employees test database that every MySQL developer or DBA should know, because it's a very common database to test. So this is how it looks like. You see it's not that big, it's 179 megabytes, and the employee tables is 22 megabytes. So, and these are the table space, right? So the scenario is that an innocent DBA will just remove a file, the employee IBD file, directly from the file system. Right, like this. So we don't know the innocent DBA, and it deletes the IBD file directly on the system. You should never do that. This is not a manual, this is not the how-to, please do it. No, you should never do that, but it happens. And it might be fun, but I know a lot of people. I am on Slack, on the community MySQL Slack, and sometimes we have people, oh, we have deleted the IBD file, we don't have, we have lost everything, so how can we recover the data? When did you did that? Oh, last year. It's over. It's over, you will not do anything, it's too late. So now, let's to control, before we did the delete, just hypothetically, let's have a look what was it that employee table. We could see that we had 300,000 records in it, right? And these are the first 10 records that were in the table. So remember, we have the first one was Giorgi Facello, and the second one was Bezalel Simel. So at least we know these two names. If we see it, it will ring a bell. And these are the last 10 by it ends by Sachin and Khaled calling the last one. So now, like I said, we delete the file, so the innocent DBA again deleted the file, and if we restart MySQL or after a while, what will happen when we will do a select in this table? It will say, oh, table space is missing. I cannot, there is an issue, right? So this is when we realize the problem, and this is why, what we will try to fix together now. So now let's go back in doing some digging to find that InnoDB data. So the first thing, every time you will see this, the first thing to do is please stop MySQL. Don't go further making stupid things and make things worse, just stop it. You stop MySQL, and in this case we were mounting a disk, just unmount the disk. Because you don't know what happened. Maybe it's the disk that is having issues, and more you're going to read or write on the disk, and worse it will become, right? Or here in this case, it's just because somebody deleted the table space, but we don't know yet, right? So the first thing to do is just try to not write and read on the disk, or do it as least as possible, and we'll see what we can do. Or for example, if you are not able to do the recovery, and with the previous tool, it could happen because it was very complicated. Today, after the session, you will see it's very easy. What we could do is create an image of the disk, send it to a consulting company to help for us to do that. But so in this case, what we do an image of the disk. And so here I use DD, and I will create a data disk image of the disk. So I will be able to use that image instead of making even worse on the disk because I don't know what happened. And then we will start extract all the InnoDB pages that we will find on the disk. Because even if we delete from the file system, it doesn't mean that the file system didn't format, low-level format of the disk. So the data is still there until we don't overwrite it, right? So what we will do, we will extract all the pages, and to do that, we use the page extractor from the InnoDB arrest tool, and we do, okay, I want to extract by tablespace, I want to do a recovery, I will put in the recovery directory, and this is my disk. So the disk is 5 GB here, because I didn't want to spend too much time showing it, but this is how we do. And then it will run on the disk and it will say, oh, I found 11,431 pages on the disk that are valid. And some pages have also failed checksum, but it found pages. So then we look at this recovery directory that we created, and we check by tablespace folder, and we see here we have plenty of files with pages, and we can see the size of these files, right? So now we know that these are tablespace with pages in it, InnoDB pages. But we cannot do anything yet with this page. So the first thing we need to do is that we need to find the table definition. What are the fields in these pages? If I don't know that, I won't be able to match data with what's in the file, right? So we need to create an SQL file that will create the table definition. If we don't do it right, it will fail. If you are a good, semi-good DBA because you did RM and you don't have a backup. But if you had a semi-good DBA, you add this dump of the DDL or the structure of the table, so it's easy. You just use it. But in our case, we are not, so we don't have it. So if we have the SDI file, you could use SDI to DDL to get the SQL create statement, but we didn't have it here. So again, this is an issue. So we don't have all that information, we will need to generate it. So this is one of the most complicated part, it's to match the data we have in the tablespace to the real structure of an SQL table. So what we do, we will try to find which pages that we extracted that we want to recover and to find the definition. So what we do here, so we search in all the files I showed you earlier, and I want to say, okay, do the IBD to SDI, and if it works, I will find some information there. So we run this. So when we run it, it will say, oh, you can see that in the first file, which was 000.pages, it says, oh, I found something, but there is nothing, I could really find it, there is no file name. But on the 0001 page, oh, there is some data here I find a file name, and it is sysconfig IBD. So something, it's a hidden tablespace that we don't have access to usually, but this is not what we are looking for. In the 002 page, what happens, we don't have a file name here either, so we cannot do anything with it. On page 3, oh, this is the department IBD, cool, but I have that data, this is not what I want. Then we can see here, it's 4, what we have is a department manager IBD, and on the 5th, something that we don't know what it is, 6, we don't know what it is, and 7, we don't know what it is. So the only thing we could say is that, okay, it is not the 3, it is not the 1, it was the sysconfig, and it is not the 4. But we don't know yet which one it is, the employee that we are looking for. So far, this is the only thing we know, and we need to know more. So do you remember this? I told you earlier when we did the pre-check that the space ID was 2 that we were looking for. but we don't know that yet. Here we completely don't know, so, but it was just to have a look. So 0, it's not that one, 1, it's not that one, so let's have a look at the number 2 this time. So what we will do is that we will run InnoDB sort on that page, because what happened is that the SDI in IBD to SDI failed to find the dictionary information in the table space because the tool tries to go at a certain offset and find the table's definition. But here we just grab all the InnoDB pages we had from the table space where they were on the disk. And they might be not sorted at that time. So here we're going to sort the data. So the next time we're going to run, so you can see, we have the 2 pages, the pages, the initial one, and then we have the sorted one. And now if I do IBD to SDI on that page, and I try to find the file name, it works. So this time it works, it found the right SDI because we sorted the pages that we had. So this is already half of a victory. We know the table space we need to recover, and we know where we can find the SDI. So when we do that, we can verify just for fun using IBD Ninja to see if it was really the right data that we are looking for. IBD Ninja doesn't support 9.0 by default right now. So I did some changes in the code. So this is the code of IBD Ninja CC, where I created I added the format for 9.0 to support it. And when you run it, my fork, you can see that, oh yeah, page 2 sorted, it's IBD, it has a space ID, it knows the size of the pages, and this looks like an IBD file, and it gives us what are the primary key and stuff like that. So it's not mandatory, this step. It just was to see if it was real a good InnoDB file. So now what we do, we have the sorted page, and we will pipe it to SDI to DDL, so what Marcello wrote, and we're going to create that employee.sql file, and this is what it creates. So now we know that in that employee table we had the first field was an integer, the second one was a date, the third one was a varchar, and so on, right? So and at least now we will be able to match the data on the page to what they are in SQL. So now that we have the page definition, we will see if it matches really. So we will now use another tool called Page Explorer with the definition of the employee.sql. I will limit to 1. I don't need to go to check all the pages. And if there is no error, it means it was okay. So here it runs, and the data that we have in the table matches the definition of the table. So we are happy. First one, it's an int, and you say it's true, it's okay. Second one, it's a date, and all that works, so we are happy. We can also run this on the sorted pages. It doesn't matter. We can run it on all the table space we have, and it will work. In case the definition was not okay, so the SQL file was not the one matching the IBD file, then we would have some errors like this. So if you don't have the error, it means it was okay. So this is what we have. Just for fun, we can also open in binary the IBD file. So here you can see I open 002 pages to see what's inside, and we can see we are finding Giorgi Facello there. So it means these are the names we were looking for. And yeah, here is the same again in hexadecimal. So we have the data, it's there. So now we can start extracting all that data. So we use the Page Explorer again, hit it to 1, and we export it to employees.json, and we run it. And what we can see here is that we have this 300,000 record that we were looking for, right? Remember when we did the select count? So now we have all these records in the JSON file. So we can see here we have a JSON file of 41 megabytes, and we will generate a CSV file that is very easy to import using MySQL shell. So this is a small one line to create a CSV file of the employee record. And then we can see we have this employee of 17 megabyte. And we can check how many records they are in, and there are 300,000 records that we are looking for. So let's have a look, and what happens here? Oh, the two first records in the table, right, are not the one I was looking for. Remember at the beginning we were looking, so can you explain why? Do you have an idea? I have the line. Yes. That's because we did it. If we check here, before here, we use 002.pages. If you would have used 002.page.sorted, it would have been sorted like we were expecting when we did the select star. But here we use the unsorted page because we can, so why not? And this is why they are not sorted, right? So remember, this is what we were trying to find, but they were not there. But it's because we use the unsorted table space file. But if we do a grep, we can see that the data is still there. So it's there, but completely randomly. You can see that 1001, it's after the 55649. So when we have that, we can run MySQL. So we can restart MySQL. Don't forget to mount the disk. And we can do set foreign key check 0 because there are foreign keys in these tables. We need to drop the table employee. It will say something in the error log about, oh, you want to delete the table, but there is no table space. We know that because we have lost it, but at least we need to delete it from the data dictionary, from everything. We say, okay, let's get rid of it. And then we recreate the table using the SQL file we have generated with the SDI before. And so we create an empty table. And when we have created the empty table, we do import table with MySQL shell. So we import the CSV file. It's a CSV Unix because I'm using Linux. And it charges everything there. So now I do a select count. All the data is there, all the records are there. I'm just doing a select. We can see we have the first one, we have the last one. So we have all the data that we were looking for. And this was very quick, very fast. For people who have done that in the past, it was very complicated. But here it's now very easy to do it. So resources, you have on GitHub InnoDB RS, you have the InnoDB sort, SDY to the from Marcello. Of course, information of IBD to SDI is also in the manual, and IBD Ninja. So share your love to MySQL and the MySQL community. There is a community Slack, you can join us there too. And before we finish, for the MySQL 30th anniversary, there is a promotion in Oracle University. And if you want, you can take these courses for free, completely free, and take one exam for free also before July 31st. So if you are interested, this is the QR code where you can take this exam and this if you want, and also the training, right? I'll let you take images, pictures. Slides will be shared. So, do you have any questions?